Hello. In this lecture, we're going to learn about the ratios. Ratios have quite a few names. We could call them fractions. We could call them rates. Usually, a rate is the most simplified form. Fraction kind of implies it, and so does ratio, but it depends really on the directions what they say. So, we are asked to find the fraction notation for the ratio. I'm going to go ahead and assume, because they didn't say do not simplify, that we are having to simplify. We always have to simplify unless the rules say otherwise. So nothing says don't simplify, we're simplifying. Our first thing that we have is 7 compared to 2. And the order tells us how the ratio is going to lay out. We always are having the numerator compared to the denominator. And that's very nice of them. It keeps consistent. So we can view this as numerator over denominator, or in this case, 7 over 2. And if we can reduce this, which we can't, we should if we are able to, but we can't, so we're done. And that's the fraction notation for the ratio. Fairly nice. So you just got to remember numerator to denominator. Now, it gets a little bit more interesting when we're finding a rate as a ratio of distance to time. So right there they told us our numerator compared to our denominator. So distance to time. Round to the nearest hundredth if necessary. So we might have a decimal of some sort being involved here. So let's start off with our first and probably only one that we're going to do for this little one. We have 55 meters and we are comparing it to 22 seconds. Now, the order here could have been in any order. It doesn't matter what they gave us. Our directions told us the order that mattered. And the order that mattered was numerator, distance, first, to denominator, time. So our numerator, there we go, there's my pen, is 55 meters compared to 22 seconds. Now, meters over seconds, we can't do anything about. They're not going to cancel out, so they're there to stay. So kind of just keep them off to the side. Now let's look at 55 over 22. It's actually a little bit easier for us to simplify this fraction before we do anything else. And I'm sorry, I can't get rid of that line because I'm lagging in my program. So we'll leave it alone. We have 55 over 22. For sure, we could have 11 go into top and bottom. And we have 5 over 2, which is a much nicer fraction to work with. But if you recall our directions, they kind of imply to us where they said round to the nearest hundredth, if necessary, that they are looking for a decimal. Ugh, come on, program. We can handle this. So, because we're looking for a decimal, let's take this fraction and convert it to a decimal. And how we do this, we take the denominator, divide it into the numerator, doesn't matter who's bigger, line up a decimal point, fling some zeros at the end. 2 times 2 is 4, closest we'll get to 5, 1, bring down the 0. 2 times 5 is exactly 10, so we're done. So our ratio, and don't forget about those units that we had, and our answer is going to be 2.5 meters per second. I'm going to cut the video short and break this off into 2 sections. This is just the ratios, numerator compared to denominator. I'm going to try to fix my program. Take care for now.